Okay, question part 1. Solve the following equation. First off, they're in different base numbers. They also tell me that x has to be a value greater than 1 and it's a real number. Okay, so that will be important when we finish. Change them all to the same base. I always go with the lower of the two numbers. Between a 4 and a 2, I change them all so that they have a base of 2, which means I don't need to touch this one. It already has a base of 2. Work with this one. So I'll apply my rule from the log tables on how do you change the base. If I want this term to now have a log with a base of 2, you put your fraction line, you'll have log with a base of 2 on top, log with a base of 2 underneath. This expression goes on top and the base goes underneath. The fact that log 4 base 2 is 2, because you just throw that into your calculator, it comes back as a nice number. Well, then I will write it as 2 instead. If it didn't come back as a nice number, like if that was log 7 base 2, you'd get a big long decimal, in which case I'd actually just leave it in log format. But it's just the fact that it does come back as a nicer number, so I'll write it as that nicer number. So I have now written log 3x minus 2 base 4 as log 3x minus 2 base 2 all over 2. And remember, division by 2 is the same as multiplying that by a half if you wanted to write that way instead. Okay? So you could write it like that if you want. Same thing. Right, so I'm now subbing that back into my equation. So the left-hand side is now going to be this expression. And it equals the right-hand side, which was this expression. Okay, next step, I don't like fractions. So they both have a denominator of 2, so I'm going to multiply both sides by 2 to get rid of the denominator. The 2's divide into each other above and below, here and here. So now you're just left with the log of the bracket base 2 should equal the log of that bracket base 2. When you have a log on both sides and they're of the same base, you can just drop the logs. And now you are left with 3x minus 2 is equal to x minus 1. Bring your x's to one side, bring your constants to the other, and tidy up. So we eventually get out that x is equal to a half. Now, at the very beginning, it told me that x had to be greater than 1. Well, a half is not greater than 1. So that means there's no solution for this. All right, so no solution. Okay, but I'm going to check just to show why x equaling a half will not work. So if I sub a half back into the original equation on the calculator, you will not be able to get out a value for the left-hand side. Calculator will say error. Okay, so I've subbed into my left-hand side of my equation the log of 3 times x minus 2 to a base of 4. And the calculator says error. There's no solution for that. Okay. If I do the same on the right-hand side, okay, log x, which is a half, minus 1, base 2 all over 2, error. Again, I can't get a solution for that. So they were correct in telling me that x has to be greater than 1. So when I got x equaling a half, it's not a solution. All right, so it wouldn't be enough to just say, oh, I'm done now. You always have to check your answer, but remember important information in the question. They told me there was a restriction on what x could possibly be. So that's question part 1. Part 2 is next. Okay, solve the following equation. Again, look at the bases. That's a base of 5. That's a base of 125. So you need to change it all to the same base. 5 is a factor of 125, so I would change that to a base of 5. Easier to go with the smaller base number. Okay, so that's what I'm doing next. I am rewriting the log of that bracket base 125. I'm going to write it so that it has a base of 5 instead. So apply the rule from the log tables. So it'll be a log with a base of 5 on top, a log with a base of 5 underneath. Then x plus 2 goes up on top and 125 goes underneath. The log of 125 base 5 is 3 on the calculator. Okay, so that's why I've written it as 3 instead. I mean, you wouldn't be wrong to leave it in log notation, but the fact that it can be written as a 3, much nicer to work with a 3 than to have to work with log notation. Okay, so I have now written the log of that bracket base 125. I can now write it like this instead. So I'm going to replace that in my equation. So my equation is now going to read as log of 2x plus 1 base 5 plus what I just converted that one into, all equal to 16. Next step, don't like fractions. So multiply across by 3 to get rid of the fraction. Simplify where you can. 3 into 3 goes once, so the fraction's gone. You're left with 3 times the log of that plus 1 times the log of that equals 3/16, which is 48. Okay. So now at this stage, there's a couple of different ways we can actually answer this question, right? But I can just apply the rules of logs. So the 3 that's in front, I can bring it up and put it to the power of. Okay, so now it will look like this. There's nothing else I can do here, and it all equals 48. Now, the rule for addition. Addition turns into multiplication. So now it's going to be the log with a base of 5, that bracket multiplied by that bracket. Now remember, that bracket is put to the power of 1, all equal to 48. Now look at the two brackets. They're actually, what was in the brackets is identical. They are the same. So then you can apply rules of indices. So this number to the power of 3 multiplied by the same number to the power of 1 means you can add the two powers. If those two brackets were not identical, I couldn't apply the rule of indices. Okay? But it's the fact that they are means I can. So now my equation reads as the log of the bracket to the power of 4 to a base 5 equals 48. And now at this stage, I can't apply any more rules of logs. So I'm going to take it out of log notation and write it in index format. So it'll be 5 to the power of 48 is equal to that bracket to the power of 4. Okay, so 5 to the power of 48 is equal to the bracket to the power of 4. You eventually want to solve for x. X is trapped inside the bracket was being put to the power of 4. In order to undo a power of 4, you could get the fourth root of both sides. Okay, getting the fourth root of both sides is the exact same as putting both sides to the power of a quarter, because a fourth root is the same as a power of a quarter. It's the same as, you know, the square root of a number would be the same as that number to the power of a half. The cube root of a number will be the same as that number to the power of a third. So the fourth root of a number will be the same as that number to the power of a quarter. And what you do to one side of an equation, you must do to the other. Okay, then you apply your rules of indices. A power to a power means you multiply. 4 multiplied by a quarter would be a power of 1. 48 multiplied by a quarter is 12. So you now have 5 to the power of 12, which is just a massive number. So I'll just leave it as that for a second. Equals 2x plus 1. Bring over the 1 and subtract it. Okay. And then you want to get x on its own, so you'll be dividing across by 2. You can now put that into your calculator and you'll get back a big long decimal. Or sorry, a big number, right? So x is equal to 122,070,313. Sorry, 312. Again, you can check if that's correct. Now, if I just go back up and look at what the restriction on the equation was, they said x had to be greater than minus a half. Well, the number I got is definitely greater than minus a half, and it's a real number. I'm just going to now check, will it solve that equation? So everywhere you have an x, I'm going to replace it with that number. Okay, so I just put in the big long number on my calculator, then I cleared the screen because it holds memory, and I type in the equation. It was the log with a base of 5, 2 times x, which is my answer, plus 1, plus the log with a base of 125 by 2 times my answer plus 1. Okay, and when I press equals, oh sorry, I'm after dropping something there. Okay, so I had it all typed in there, right? Log base 5, 2 times your answer plus 1, plus the log of base 125 by 2 times your answer plus 1, and I got back the 16. Okay, so I know I'm correct. Now, there is another way we could have done it. So when we got to this stage, all right, and I multiplied across by 3 to get rid of the fraction, that's grand. But there is another way you could do it. So I'm going from this line right here, and I'm answering it in a different way, okay? Remember what division by 3 actually means. Division by 3 is the same as multiplication by a third. So I could rearrange this term and write it as 1/3 of the log of that bracket base 5. So I could write it like that instead. I could then apply the rule of logs where I bring the number up in front and put it on the power. So I could write like that. Log the bracket to the power of a third, base 5. And then at this stage, addition turns into multiplication. So it's going to be the log of that bracket multiplied by that bracket, base 5, all equal to 16. Rules of indices come into play here. Because the two brackets are identical numbers, 2x plus 1 is in both brackets, I can add the powers and get a power of 4/3. Okay, top heavy fraction, 4/3. At this stage now I can't do any more rules of logs, so I take it out of log notation and I write it in index format. 5 to the power of 16 is equal to the bracket to the power of 4/3. Okay, you want to solve for x. X is trapped inside the bracket is being put to the power of 4/3. In order to undo a power of 4/3, I need to turn it into a power of 1 basically, and then the bracket will be on its own, so it would be like this, 2x plus 1. The only way to turn 4/3 into a 1 is if you multiply 4/3 by its reciprocal. What do I mean by a reciprocal? The reciprocal of any fraction is that fraction turned upside down. So 3/4 would be the reciprocal of 4/3. Okay, so by putting the right-hand side to the power of the reciprocal of that power to a power means you'd multiply. 4/3 multiplied by 3/4 will give you a power of 1, which means the power is gone. But remember, if I do it to this side, I have to do it to the other side as well to keep the equation balanced. Okay, and apply a power to a power. 16 multiplied by 3/4 is a power of 12. So now you'll notice where I'm at now with my equation. So 2x plus 1 is equal to 5 to the power of 12. That's what I had when I did it the other method. I had 2x plus 1 is equal to 5 to the power of 12. So the rest of it then is the exact same solution. Okay, so again, that is just division by 3 is realising that's the same as multiplication by a third and just applying different rules of logs, that's all. Because there's always more than one way of doing things, okay? And again, the only reason I am allowed to apply rules of indices here is because the numbers inside the brackets were identical. If they were not identical, then I could not apply the rule of indices where I can add the powers. Okay? And again, to undo a power of 4/3, I just have to put it to the power of its reciprocal. And if I do it on this side, I have to do it on that side. And remember what a reciprocal is. It's just the fraction upside down. All right. Now, there is one other way I could have answered it as well, so I may as well show you that way as well. So let's say when we were at this stage and we multiplied across by 3 to get rid of the fractions, and we got this equation. Right, so I can do a different way than this method. This will be a third method. So I'm at that line right there, okay? So this is where I was. Now, those two brackets are identical. So the fact that they are identical means this term is a like term with this one. It's like, you know, you'd group all your y's together, you'd group all your p's together. Well, I can group all of my log 2x plus 1's base 5's together. So it's only because the two brackets are identical that I can do what I'm about to do. So if they are like terms, okay, like that's 3 times x plus 1 times x, you could say, or call them p's, I suppose. I don't want to confuse you with x's. That's the same as saying 3p plus 1p equals 48. All right. So remember, there is a 1 in front of that log. So given that the two logs are like terms because the brackets are the same as each other and they're both bases of 5, I could literally just say, well, 3 plus 1 is 4. So it's 4 times the log of the bracket base 5. So again, it's like saying 3p plus 1p equals 48. Well, therefore, 4p equals 48. So it's a much more simplistic equation. Now, at this stage, you can do two different ways again. You could divide across by 4 to get the log on its own. So if you divide this side by 4, you have to divide 48 by 4. That would then leave you at log, sorry, I'm on this side. That would leave you at the log of the bracket base 5 is now equal to 12 because 48 divided by 4 is 12. Then you'd take it out of log notation. So it would be 5 to the power of 12 is equal to the bracket. And now you're at this stage, which is where I was when I did it the first method. Okay, so I'm at the same equation, so you're just solving for x after that. Okay, to get out that large 122 million figure. If you don't want to do it that way, okay, the power of 4, or so the 4 in front of the log, I could bring it up and put it on the power of the bracket, so it would look like that instead. And again, I can't apply any more rules of logs, so I'd take it out of log notation. It would be 5 to the power of 48 is equal to the bracket to the power of 4. Okay, you eventually want to get the bracket to the power of 1. So how do you undo a power of 4? You put it to the power of a quarter. It's reciprocal, or you could get the fourth root of both sides. What do you do to one side? You must do to the other. So I'd get a power of 4 on both sides. Apply rules of indices. Power to a power means you multiply, so you'd get a power of 1. 48 multiplied by a quarter is a power of 12. And now I am back to the same stage I was here. Okay, out and solve it and you get the same answer. So I've now solved that equation 4 different ways and I'm getting the same answer regardless. Okay, part 4, solve the following equation. Again, look at the bases, they are different. So you need to bring it all to the same base. Given that 3 is a factor of 27, I'd bring everything to a base of 3, which means I have to adjust this one. So I am rewriting the log of x plus 2 base 27. I'm writing it so that it has a base of 3. So again, you'll have your x plus 2 will go on top and the 27 goes underneath. And they both are a log of base 3. Now, log 27 base 3, if you put that into the calculator, you'll get back a nice whole number of 3. So I will do that. If it's possible to do it, I do it. So now I can replace the log of that bracket base 27, I can replace it with this in my equation. So now my equation will look like this. So everything is in a base of 3. So I could solve it a couple of different ways. The first way I'd be thinking is get rid of the fractions. Multiply across by 3 to get rid of the fraction. Then simplify above and below where you can. 3 into 3 goes 1, so it's gone. So you're left with the log of that bracket base 3 plus 3 times the log of that bracket is equal to 3 fours or 12. Okay, now you can answer the next part a couple of different ways as well. If you notice, the brackets are identical, so they are like terms. So the quickest way would actually be to have copied that. That's 1 times the log of the bracket plus 3 times the log of the bracket, which means I would have 4 times the log of the bracket equals 12. If you don't want to do it that way, grand. You could bring the 3 up and put it on the power. And then it would look like this, plus the log of the bracket to the power of 3 base 3. At this stage then I can't apply any other rules of logs, bar the addition rule. So addition turns into multiplication. So it would be the log of that bracket multiplied by that bracket to a base of 3 equals 12. And again, given that those two brackets are the same as each other, there's a power of 1 on that bracket, so I can apply rules of indices. Add the powers and you get a power of 4. And I can only do that because those large numbers are the same, they're identical. Next step, take it out of take it out of log notation. So it'll be 3 to the power of 12 is equal to the bracket to the power of 4. Next stage, you want to get rid of the power of 4 on the bracket. So how do you undo it? A power of a quarter. And what you do to one side, you do to both sides. Okay, power to a power rule, 12 times a quarter is a power of 3 and 3 cubed is 27. 4 multiplied by a quarter is 1, so you just get left with the bracket to the power of 1, so x plus 2. Bring over the 2 and subtract it from 27, so 27 take away 2 is 25 and you've found x. You can check if that's correct, and if I go back up here, they did say that x had to be greater than minus 2. Well, 25 is definitely greater than minus 2, and if I sub 25 in for x, the whole thing will equal 4, so I know I'm correct. So that was one way of doing it, okay, where I got rid of the fractions, I multiplied across by 3. If you don't want to do that method, by the time you get to this line, division by 3 is the same as multiplication by a third. So I'll do it that method as well. So again, as I said, division by 3 is the same as writing this a third of the log. You can then bring the 1/3 up and put it as a power on the bracket, so it'll look like this. Okay. Then it's the addition rule to multiply the two brackets together. Remember that bracket is to the power of 1. And the fact that the two brackets are identical, rules of indices, add your powers. 1/3 plus 1 whole unit gives you 4/3. Next step, take it out of log notation. So it'll be 3 to the power of 4 equals the bracket to the power of 4/3. I eventually want to get x on its own. It's trapped inside the bracket to the power of 4/3. So to undo a power of 4/3, I'm going to put it to the power of its reciprocal, which will be 3/4. And what I do to one side, I must do to the other side. Power to a power means you multiply. 4/3 multiplied by its reciprocal will give you a power of 1. 4 multiplied by 3/4 gives you a power of 3. 3 cubed is 27. So 27, bring over the 2 and subtract it, and you get 25. So I'm getting the same answer, I just did it a different method. There is a third way of doing it. Again, when you were at this stage, get rid of the fractions, multiply across by 3, simplify above and below where you can. Okay, and then you're left with this stage. Now again, because the brackets are identical, if you can note, and the quicker way would be, they are like terms. So that's 1 log the bracket, that's plus 3 log of the bracket. So if they're like terms, 1 plus 3 would give me 4 times the log of the bracket, base 3 equals 12. Then you can either divide across by 4 to get the log on its own, right? If I do that, it will look like this. Divide both sides by 4, you'll just get the log of the bracket base 3 is now equal to 3. Take it out of log notation, so it'll be 3 to the power of 3 equals the bracket. 3 cubed is 27. Bring over the 2 and subtract it, and you get 25. Or alternatively, you could bring the 4 up and put it on the bracket as a power, like this. Then take it out of log notation, so it'll be 3 to the power of 12 is equal to the bracket to the power of 4. You want to get the bracket to the power of 1, so again, put both sides to the power of the reciprocal of that, which is 1/4. What you do to one side, do to the other. And then it's rules of indices, power to a power, you'll get a power of 3. 4 multiplied by a quarter gives you a power of 1. 3 cubed is 27. Bring over the 2 and subtract it, and you get 25. So again, that was kind of 4 different ways of getting the exact same answer. And they'll never specify what way you're to answer it. Like, they will just say solve, and you go off and do it whichever way you want using your rules of logs. Okay, the last one, it was part 5. The log of that bracket, base 27, plus the log of that bracket, base 81, equals 5/6. X has to be greater than -2, and it has to be a real number. Okay. You have a 27 and you have an 81. We need to bring them to the same base. Now, you could bring them both to a base of 27. That's grand. But if you notice, you've got a 27 and 81. they both share a lower factor of 3. 3 would go into both of them. So I'd actually be more inclined to change them both to a base of 3. But you would not have been wrong if you want to change them both to a base of 27. Okay? The only thing is with changing them to a base of 27, that one will end up looking complicated looking. Okay, because 27 is a large number. Whereas it'll be more simplistic if I change them both to a base of 3. It just does mean a little bit of extra work with changing the base. So I'm going to change the base of this one first. Okay, so I've put it down here. I want to change them both to a base of 3. All right, so again, the bracket goes on top, the 27 goes underneath. Log 27 base 3 is 3. Okay, now I'll leave that just for a second. Come down to the other one. So I now want to change this so that it also has a base of 3. So again, I'll put log with a base of 3 above and below. The bracket goes on top and 81 goes underneath. Log 81 base 3 is 4 on the calculator. So now it looks like that. Now, look at those two brackets. I'll go back up to the two brackets. If they can be factorized in any way, you have to do that. Now, 2x plus 4, that can be factorized, highest common factor, 2. So I'd factor out a 2 from it. You have a 6x and a 12. Again, highest common factor between the two of those would be 6. So if any factorization can be done, you have to do it. Otherwise, it will get really complicated looking if you don't, okay? So at this stage, I'm doing factorization to that little bracket. Factor out a 2, and I suppose I'd keep that little 2 in a bracket by itself as well, like that. And you're left then with x plus 2 inside the bracket. And the same for this one, okay? They both contain a 6, so I'm going to factor 6 out from both of them. And again, I would just keep that 6 in a little bracket. You would then be left with x plus 2. So 6 into 6x goes x times, 6 into plus 12 will go plus 2 times, and it's all over 4. Okay, I am now going to rewrite the original equation. So that was the original equation, and it's all equal to 5, 6. But I have now rewritten this as this fraction, and I have rewritten this as this fraction. Okay, so I have now rewritten the original equation after I had changed the bases and factorized out what was common. Next step, don't like fractions, so I'm going to multiply across by the lowest common multiple, which is 12. Okay, they'll all divide into a 12 evenly. Then you simplify above and below where possible. 3 into 3 goes once, 3 into 12 will go 4 times. 4 into 4 goes once, 4 into 12 will go 3 times. 6 into 6 goes once, and 6 into 12 will go twice. So 2 times 5 will give you 10 on the right hand side. You're left then with 4 times the log of that plus 3 times the log of that equals 2 5s are 10. So that's now my equation. All right. Now, you can, again, solve this many different ways. I would bring the power of 4 up and put it on the bracket. I'd bring the power of 3 up and put it on the bracket. So now it will look like this. All equal to 10. Now, remember, that entire bracket is being put to the power of 4, which means the 2 is being put to the power of 4, and the x plus 2 is being put to the power of 4. In this bracket, the 6 is being put to the power of 3, and the x plus 2 is being put to the power of 3. That's important. So I'm just going to write them out separately then. So 2 to the power of 4, that's 16. The bracket to the power of 4, leave it as it is. 6 to the power of 3 is 216. And then that bracket to the power of 3 just stays as it is. All equal to 10. Okay. So now at this stage, I can apply the rule of addition. Addition turns into multiplication. So I can now have the log of this expression multiplied by this expression to a base of 3 should equal 10. Okay, I can tidy this little square bracket up further. They're all being multiplied together. So you can multiply 16 by 216 first. And then look at your two brackets, they're identical. X plus 2 and x plus 2, which means I can apply rules of indices. They're being multiplied so you can add the powers. 4 plus 3 will give me 7. Okay, and 16 times 216 gives me 3,456. So I can't do any more with the rules of logs now at this stage. So take it out of log notation and write it in index format. So it's going to be 3 to the power of 10 equals that expression. Okay, now 3 to the power of 10 is just 59,049. So rewrite it like that. I want to get the x on its own eventually. X is inside the bracket is to the power of 7, and then it was multiplied by 3,456. Undo the 3,456 first. Get rid of it. Divide both sides by 3,456. Then you will be left with the bracket to the power of 7 on its own. And 59,000 And 49 divided by 3,456 simplifies to this fraction, so I'm not even going to bother writing it because it doesn't come out to be a lovely number or anything, so I'll just leave it as it was. So I'll leave it as that top-heavy fraction, okay? The next step, I want to get the bracket on its own, so I want to get the bracket to the power of a 1. So I need to undo the power of 7. The opposite, or the reciprocal of a power of 7 is a power of 1/7. And what I do to one side, I have to do to the other. So I'm going to get a power of 1/7 on both sides. Power to a power means we multiply, so that will then just leave me with x plus 2. And you can put that into your calculator and put it to the power of 1/7. And you'll get back 3/2, or 1.5 as a decimal. Bring over the 2 and subtract it, and you will get x is equal to -1/2. You can then check if that's correct by subbing it back into the original equation. And remember, they had told us that x has to be greater than -2. Well, -1/2 is greater than -2. It's a larger number. So that's correct, but you do have to check, does it actually solve the equation? So I would sub in, everywhere you have an x, sub in -1/2 in a bracket, press equals, and you should get 5/6. Okay, that will be the correct answer. Now, that was coming from having to do a little bit of factorization so that your brackets end up being the same at this stage so that you can apply rules of indices. Okay, if you don't do that factorization, so if you had left this in that format and if you had left this one like that, look at what your equation will become. So it'll look a lot more complicated. Still doable, but it will look much harder and you'll think that you've done something wrong. So when I get to this stage, right, and I didn't bother doing the factorization of the two brackets, I got rid of the fractions by multiplying across by 12. I simplified above and below next. Then I got this line. Okay. I brought the 4 up and put it on the power. I brought the 3 up and put it on the power. So now it looks like this. Addition turns into multiplication. So now I would be saying the log of this bracket multiplied by this bracket to a base of 3 equals 10. Now, because those brackets, they no longer look the same like what they did when I did the factorization, you can't apply rules of indices. I cannot add the powers now because my base numbers are not the same. So all I can do next is take it out of log notation and write it in index format. So it'll be 3 to the power of 10 is equal to all of this expression. Now that looks really complicated looking. You're not going to go off multiplying out that bracket to the power of 4 and then multiply the answer by that bracket to the power of 3. You'd end up with a degree 7 polynomial. Okay, it's not helping you. It's making it even more complicated looking. So when you would get to this stage, most of you would think, oh, I can't solve this. I've done something wrong. I'll just leave it. Now you can solve it, but you still have to go off factorizing. So you'd still have to say, right, well, I'll pull highest common factor out of that, right, which would be 2. You'd open a bracket, you'd get x plus 2 inside the bracket. And then the whole thing was being put to the power of 4. For this, again, 6 is the highest common factor. So you'd pull out a 6, you'd open a bracket. 6 into 6x goes x times 6 into 12 goes plus twice. All to the power of 3. Then 2 is being put to the power of 4. That bracket is being put to the power of 4. Write them separately. 6 is being put to the power of 3. And the bracket is being put to the power of 3. Write them separately. 2 to the power of 4 is 16. 6 cubed is 216. That bracket to the power of 4, that bracket to the power of 3. And now, if you notice, your brackets are identical. Which means when they're all being multiplied together, the order that we multiply doesn't matter. So I can multiply the 16 by the 216 first to get 3,456. And then if I multiply that bracket to the power of 4 by that bracket to the power of 3, I can apply rules of indices now because the brackets are the same. So add the powers, 4 plus 3 will give me a power of 7. And now I'm back to the stage I was when I did the factorization earlier on in the question. So divide across by 3,456. Okay, to get the bracket to the power of 7 on its own, and then you'd put both sides to the power of 1/7. Okay, and I'd be back at this stage where I was originally, to eventually solve for x. Alright, so factorization has to be done regardless of when you do it. I would much prefer to do it at the earlier stages of the question, because you'll be less likely then to make mistakes. So after I changed the base, that was when I did the factorization. So if factorization is possible at all, for any expression in a bracket, always do it. So you could have done it at the very beginning here before you even went to changing the base. All right, but you have to do it at some stage. Otherwise, you'll get to a certain stage and you'll think, I've gone wrong. How in God's name do I solve that? Well, you solve it by doing the factorization now. Okay, so that was part 5, wasn't it? Yeah. Okay, and again, my answer was -1/2. Okay,